Good morning. I'm so happy because I finally get to lecture you guys. It's been 2 weeks, and many things have passed. It feels good to finally be getting to talk to you guys directly, and definitely good morning, Victoria. Victoria, I've got Slack open on my phone here on the podium, so I'll be able to see questions pop up, but if I do miss one, I know this cohort's really good about yelling at the instructor. So yesterday we played with CSS, which is fun. I say fun because I like CSS. Most people end up in that scene from Fight Club where he's collapsed against the wall just punching himself in the face. That's how most people typically view CSS. I want to change gears and sidestep from CSS for just a minute, because what I want to focus on today is client-side JavaScript, meaning JavaScript in the browser. And if we're focusing on JavaScript in the browser, then we have actually come home in terms of JavaScript, because this is where JavaScript was invented. JavaScript 1998 in the Netscape browser originally. The stories are true. It was originally written in 10 days. It's gotten better a bit. And the nice thing is, because it has been around that long, it has absolutely matured. But this is where it started. Where we started was being able to add interactivity to what we were doing in the browser. For those of you doing the math, it is 21. That means it's old enough to drink in the States. So, couple interesting things about JavaScript when we shift from using it as a full-fledged programming language to doing it just in the browser is we have to understand what JavaScript's role is. And in order to understand JavaScript's role, we first have to break down the other two things that we are dealing with. We have HTML, we have CSS, and we have JavaScript. This often gets called the web trifecta. I didn't make the term up. It's on the Googles. You can find it. But each one of these things has a very specific role. And there's actually a fourth one, which we have to kind of sneak in at the top, because without it, the web would be pointless. And that's the content. So whenever we are looking to do something in the client, there's 4 different aspects we have to consider. We have to consider the content, because that's what someone is actually going to view. And then we have to think about HTML. And if you've ever gone online and done like a Udacity course or Udemy or Codecademy, Coursera, pick any web course that's out there. If you went to your local community college and got taught how to build web pages, I'm going to personally stand here and say something terribly controversial, which is that you were taught the wrong thing about what HTML is and does. Because most courses are like, if you want your content to look like this, use this tag. Wrong. HTML has a very specific role. HTML adds context to content. We make the analogy a lot. We would make the analogy if Nick was on time to lecture. I give him shit every day. Because he's late every day. Sorry, Victoria, sidebar. We make the analogy a lot of HTML being like the scaffolding, the framing of a house. And we show the pictures with the the wooden beams and everything before drywall and paint and carpet and everything have been added. And we use that to talk about HTML giving structure. But here's the way I want to start off and change your brains to think about that. And since this is your first front-end week, it's a good time to do so. Those walls that we see that are framed out in wood, yes, that is the structure of the house, but each one of those walls, each one of those shapes that it creates is creating a context for that space in the scope of the whole You know, the living room is this much space, 12 by 25 or whatever, in the scope of the whole. The closet has a weird dog leg in the back of it. That's the context of that space. The bathroom's always too small. All these things that there's a certain context given to that space because we have drawn that box around it. Well, if we think about putting content online, if I was to just sit down and write my name and write, Lighthouse Labs and write Vancouver and write coffee because coffee, I can write these nouns down. I can list these things, and they make sense to us as humans. We can view this list and go, okay, the first one's his name, it's separated by a line, and everything else. But if I was to view this in the browser, what would happen? Anyone? Bueller? If I just saved this, as blah.html and loaded it in the browser, what would happen?
It would probably be one line or maybe lines like that. I'm not sure how
You were actually right the first time. So the answer there is that it would just be one line. Yeah, plain text. Sammy said it right. The browser views this as plain text. And the reason is the computer doesn't see any one of these items as any different than anything else. There's no context to these. So if I come up here and I now do this, if I'd save this as an HTML file, it would have been much easier in Sublime. It's the only thing I like about Sublime is that it auto-finishes tags for you. So if I do this and wrap it around, now, ta-da, there's context. And even as a human, even though the markup is there, even though I have marked up the content to indicate what it is I want the computer to understand, I can still read it as a human. In fact, if anything, it's actually clearer to me as a human what the context of all of these things is. So when we are writing tags and building HTML, we are building a certain context around our content. And I promise this is going to be relevant to JavaScript in just a minute. So then we get to CSS. And CSS is the appearance of that context. Now, and this is where I say that, everybody else gets it wrong when they're teaching HTML, because they'll be like, oh, well, if you want it bold, put it in a strong tag. The strong tag has nothing to do with bold. The strong tag says this is a bit of content which should be interpreted as the author feeling more strongly about it than everything else around it. An emphasis tag is not automatically italics. What happens is the default style sheet that exists in each browser styles it that way as a way to distinguish it from other tags. But I can override that with CSS. Everything that I do as a developer with CSS is to override properties in order to get the appearance that I want for the context that I set. So I use HTML first to create my context, and I use CSS to determine what the appearance of that context is going to be. I'll let Jo have a pass because she's never late. And then, last but not least, I have my JavaScript. And my JavaScript is how I interact with the context. I've put the content in a particular context, and now I want to interact with that. Because content that I would have up in a header, I'm probably going to interact with far less frequently than content that I would have in a list or in a form or in a comment or something like that. Depending on the context of where that content is, changes how I, as a user of that particular application, am going to interact with it. And this is all very philosophical at this point, but The reason I get philosophical about it is because if we understand what each one of these pieces' role is, it becomes far easier to separate the responsibilities and focus in on what it is we actually have to create. Are things like strong and EM useful for SEO? Do they communicate anything useful to the browser without any stylings? Oh my gosh, yes. Awesome question, Gabe. Thank you. So what they're asking here is, when we put tags like strong and EM around content and give it a particular context, does that change how things like the Googlebot interpret it? Yes, 1000% yes. That's also why the semantic tags, section, main, article, header, footer, that's why those are so important, because those are very clearly defining the roles of that content within the page. So what ends up happening is Google will look at the first H1 on the page, as an example. It'll look at the first H1. That is the most important title on that page. Those are the most important keywords on that page. And the neat thing about that is then, as we are going through things like links, that's why the title attribute on anchor tags is so important, because those are the keywords that get associated with that link. And if we have, say our blog post of text, and inside there we have used those tags like strong and emphasis, those words are considered to be stronger keywords and have a higher density for that content than the other text around it, because we as the authors have chosen to add that strength or add that emphasis to those particular terms. So yeah, these tags actually become our indicators to anything that is understanding our content for what we actually meant. Literally, HTML becomes our do what I mean, or understand this the way that I mean, because we are able to communicate our intention with that. So yeah, the tags we use are incredibly important. So now we're at a point where, okay, we've got some ground rules laid down. We always start with content. We add context to that content. We decide how that context is going to appear. And then we choose to add JavaScript to be able to interact with that content. And that has been the intention of JavaScript for pretty much since its inception. I mean, on the one hand, Netscape, went to Brendan Eich, who's the guy who originally wrote JavaScript, and they were just like, hey, we need a scripting engine for the browser. But he had to go through these mental gymnastics in order to figure out what role that scripting engine was actually going to play. So here's where we get to kind of peel back the curtain. Oh, wait, quick question. Has anybody not seen The Wizard of Oz? Spoiler alert. So they get to the Emerald City on the Yellow Brick Road, by the way. I'll just give you the Cliff's Notes. Rotten Tomatoes gives it like a 95%, so it's okay. They get to the Emerald City on the Yellow Brick Road, and they get into the big temple, and there's the big head floating there, roaring at them. And Toto runs over, and being the scruffy little dog that he is, he grabs the corner of this green curtain and pulls it back. And behind the curtain, we see the guy with all the gears and the levers and everything else. And the big head booms at us, pay no attention to the man behind the curtain. And we see that it's just the guy talking into a microphone. So here's where we get to, as devs, pull back the curtain on what's actually going on in the browser when it parses a web page. So I'm going to give you a very little known fact. Yes, we write HTML, and yes, we write CSS. At the end of the day, when we are actually interacting with our content in the browser, everything is turned into JavaScript. What ends up happening is the browser parses the HTML and parses the CSS in order to create programmatic objects in memory that it can work with. So then all the clicks, all of the CSS styles, all of the drag and drop or anything that we might do is actually being governed by JavaScript objects with series of properties on them. And we call this the DOM, and that stands for the Document Object Model, which is a acronym that has nothing to do with 50 Shades of Grey and everything to do with the fact that we create a big tree of objects. If you remember, working with like objects inside of arrays inside of objects, back in week 1, your URL database for TinyApp, went through a couple different permutations of being an array of objects and then an object of keys of objects. So that kind of complex data structure is what the DOM becomes. As each tag is interpreted by the browser, as each CSS property is interpreted by the browser, an object is created for each tag, and all the CSS becomes properties. And any other JavaScript that we run is just running on those objects that are sitting in memory. So that's why this becomes really cool, because once you have an understanding of how JavaScript works in the browser, you literally can change everything. As long as you can access the object and find the property you need. And that becomes pretty easy once you know how to read objects, which, cool part, you already do. So, the DOM is a remarkably powerful thing, and let's actually look at some HTML. So I will re-warn you, I do all my coding in Vim because that's where I'm productive. Sublime and I have a love-hate relationship, mainly because I love to hate it, and it loves to frustrate me. So all my coding is done in Vim, but here we have a pretty basic web page. And a couple of things I want to point out about this web page before we dive any further, and this mainly comes from things I saw popping up when I was mentoring yesterday. And I'm going to start off with this line at the top. What does that do? Shmi.
Sets HTML5?
Yes. So sets HTML5 is the answer here. That it sets the rules that the browser is going to follow for interpreting all of the tags and all of the CSS properties. Funny story, brief anecdote. So when I used to be the senior dev at Metro Lyrics, we would get ad campaigns from iTunes. And when HTML5 first started coming out, yes, I worked there a long time ago, when HTML5 first started coming out, we would get these panicked phone calls from their ad teams, who of course knew nothing whatsoever about technology. And they would almost be yelling at us frantically, "These ads have to be HTML5 compliant. Is your page HTML5 compliant?" We're like, yeah. Are you sure? Have you recoded everything to be HTML5 compliant? Yeah. And it got so bad that we eventually ended up on a conference call with the VP of engineering, quote unquote, for this marketing team. And again, knew nothing about technology, but he was a VP of engineering, go figure. And he was like, my team keeps telling me that you're assuring them that your page is HTML5 compliant, but we have to be sure, because this was, Lady Gaga was releasing a new album, and so it absolutely had to work in HTML5. That's what all the ads had been built in. And we're like, look, we're really, really sure that our page is HTML5 compliant. And he's like, well, okay, just walk me through this, explain like I'm 5. How is it that you know that your page is HTML5 compliant? And we're like, we had him load the page, right-click, view source. We're like, you see that line up at the top? Yeah, that means it's HTML5 compliant. And he's like, seriously, that's it? We've had other vendors telling us it's going to take them like a month to recode their page to be HTML5 compliant. We're like, no, they put that line at the top and it just sets the rules. And then we took him to the documentation and showed him, this is what it does. And he's like, I have to make a few phone calls. So yeah, once I have that, all the rest of my page is automatically interpreted as HTML5, which is awesome. Because it means that a lot of the stuff that I see online when I am doing the standard coder's trick of copying and pasting from Stack Overflow, knocking on wood and praying that it works, there's a lot of stuff in that that I don't need. For example, you will see a lot of this, the type attribute, on link tags and on script tags. Unnecessary. At this point, it's not even decorative. That used to be necessary in HTML4 when we had to tell the browser what type of link it was, because there are multiple things that we could have used the link tag for. Pardon me. The other thing that comes up is this, type equals text JavaScript. We used to have to do that because there was this horrible thing that used to exist on the web called VBScript. That was Microsoft trying to inject their scripting engine into the world, and it was, oh, how do I put this politely? It's shit, like just complete shit. That's the nicest way I can say it. VBScript was a horrible, horrible thing, and it died a death, and that's good. End of my opinion. So we don't need to do that anymore. We don't need to specify a type for that script anymore, which cleans up the stuff that we have in the head quite nicely. There's enough weird things, like when you get into the meta tags and stuff like that, there's enough weird things that have to go in the head that if we can be clean about what's going in there, it's less processing we have to do. And one of the things I want to say about tools like HTML5, and especially when we get to the dev tools in the browser, is these tools do something really neat. And the way I'm going to say it probably sounds tongue-in-cheek, but I'm being dead serious. They keep you from having to think. And when I say keep you from having to think, I mean keep you from having to think about the unimportant things. They allow you to spend the mental cycles focusing on the stuff that actually matters, like the content, the context, the appearance, the interactivity, not the syntax. The syntax should not be the thing that bogs you down. Syntax is Googleable. And if I can use less syntax, I need more thumbs. So HTML5 allows us to clean that up a bit, but it also means that we can bring in the full suite of the semantic tags. So I have wrapped everything inside my body in a main tag. If I was going to have a nav bar above that, that would probably be outside of main. And I can have a header, I can have a nav, I can have a footer, I can have those tags, and wherever I put them, they are in the context of the body of my page or in the context of where I've put them. For example, I have a section tag here. That section has 2 articles inside of it. Article does not mean newspaper article. Article means article of content. And then in my section, I have a footer. That is semantic, that is contextual. That footer is for that section and that section alone. It's not for the whole page, it's not even for main, and certainly not for the body. It's just for that section. Using these semantic tags lets me set the right context so that when I'm adding JavaScript to interact with it, I'm getting to interact with the right things. Everyone follow me so far? Any like eye glaze juice going on? Cool. Victoria, can I get a thumbs up from you guys if you guys are okay? Which is my cheap excuse to drink coffee. Awesome. Okay, so let's look at what this page actually does. That's not it. That's it. It's beautiful. I spent pairs of minutes styling this, so you'll forgive me if I wasn't going after design awards. But nice, straight, simple. And what this page does is it gives me a platform with which to start to demonstrate what it is that JavaScript is creating. So now we can use this image and talk about what we're seeing. So we saw that web page, we saw the code. It's pretty easy to look at that code in the page and go, okay, one of these translates into the other, pretty straightforward. but we have to understand there's things going on that we don't see that are part of the JavaScript world that has been created. So, I love this image because it represents what's going on when that page got rendered. There are a number of JavaScript objects that exist above and beyond just what is on the page. So, you see that we have a whole nested structure going here. And on the outside is something called Navigator. And Navigator is representing the state of your client itself. Navigator is basically the client application. So in this case, Chrome. And it represents that application and its relationship to the overall system it's running in. Navigator is where we are able to get device properties. Navigator is where we are able to access things like geolocation. Navigator is how we can, we can find out the battery status through Navigator, for example. We can make the screen or make the device vibrate if that is supported. I can't make my MacBook vibrate because that's not installed, but theoretically I could have a web application where I access the vibrate function that could vibrate my phone, if that was enabled. So that is our outer context. Everything is contained within Navigator, which makes sense because the web page is loaded in Chrome. Inside of that, I have window. Window represents the specific tab in which I am running my page. Each tab gets its own window. It is its own window. And window is our global object in JavaScript, in the client side. We don't have window when we are coding in Node for obvious reasons. If they're not obvious, see me after class, I'll draw you a picture. Sorry, that was mean, but I'll still do it. But window is where all of our global stuff is. Like we still have, for example, console.log on the client side, but window.console is where we get that from. The same way as in Node, if we're coding in Node and we run console.log, technically that's coming from global.console.log. You can run both things and you'll get the same impact. So window is where all of our global things are stored. All of the native JavaScript methods and properties are all stored as properties on the window object. Any global variable that we create, any function that we define in the global context, all of them go as properties on the window object. Window is also, for example, where we can change the address of the page and actually redirect the page to a new place. That's window.location. And so then inside of window, we have document. And document is our DOM object. Document is all of the DOM built into it and all of the methods to access that DOM wrapped into a single object. And just for what it's worth, I'm going to go ahead and call out what I use as my definition of a code object. A code object is an object that contains data and the methods to act on that data as a single unit. So for example, if document is all of the tags, all of the CSS properties for those tags, that also means those are the methods to look up any one of those tags, any one of those elements on the page, and interact with it. So those are wrapped together as a single thing. Inside of document, you can see that we actually have the structure of our page in there. We've got head and body as siblings, which means there's document.head and document.body. Those properties are at the same level of depth inside of that object. And then inside of body, that is where all of the tags that are inside the body would go. And while it is entirely possible to do like document.body.this.this.this.this and get deep down to a certain tag, that gets tedious really quickly. And one of the things that I want to start off by telling you, and you'll hear me say this a couple of times throughout the course, assuming I get to lecture you again, is languages have a particular quirk about them, especially very mature languages like JavaScript, in that if you're in a position where it feels like what you're trying to do is really, really hard, like you're really having to bend the laws of the universe to make something happen, you're probably going the wrong direction. And you know, we've seen this with a lot of things. You know, the idea of, let's say, for example, making a route that's going to delete a URL in your tiny app database turned out to be like, what, 4 lines of code at the end of the day? So, you know, what seemed like it was going to be a lot of work, once you understood how to properly access the particular data you needed, it was delete that key and redirect to /URLs. At the end of the day, not terribly hard, once you understood the right way to do it. But if you were then writing for loops and finding the right key and then rebuilding the URL database without that particular key in it, and then resetting things and trying to do, you know, more work than was necessary, you were probably sweating. So this is where we start to explore what these methods are that allow us to interact with this particular object. So, we've got 2 boxes and a button, and I'm going to bring up the dev tools. And let's make these a little bit bigger. So in my dev tools, I can go to my Elements tab, and of course I can see all of my elements that are selected. And I can see that inside of body, body only has 1 child. So if I bring up document.body, and notice how that the dev tools are auto-completing the property names for me, very helpful. When I bring up document.body, it gives me a reference to that body, and I can see what's inside of it. Now, if I try to do document.body.main, that doesn't exist. And you're like, okay, Don, you lied to me. You told me that this was a whole tree of objects and that I could just traverse it and find what I needed. I did. What I didn't tell you is that the tree of objects isn't just based on the tag name. Each and every element, when it is parsed by the browser, becomes something called an HTML node. And each node then has properties on it. And especially once we get inside the body, where things are nested and potentially nested quite deeply, we want to start using the methods that are provided to us in order to find things. So I have a method called document.getElements by tag name, for example. And when I call that, I can put in something like the string main, and I get back something very specific. I get back an HTML collection. That is a very specific type of data that JavaScript is going to give me back. And if I look at what is in there, I can see that basically it's an array that has 1 element in it, and that 1 element is named main. So if I make a variable, and I run the same thing again, and then I look at what main element 0 is, because it's an array, therefore I can access it with array context. There's my main. Now the question is, and this is one where I'm going to make you think this early in the morning, my apologies, why did I get back an array? And is there anything in the method name which let me know that I was going to get back an array?
What do you mean by method name?
In the actual method I ran, get elements by tag name, like that's the name of the function I ran. Is there something there that tells me that I'm likely to get back an array? Yeah. I'm asking for not just an element, elements. So, yeah, the pluralization in this case matters. If I'm running a method that says get elements, I'm guaranteed to get back an array. Contrary to that, I have, well, we can see the get methods I have. I have get element singular by ID, which makes perfect sense because an ID should represent a unique element on the page. Get elements by class name. Classes can be set on more than one thing, so therefore if I'm getting elements by the class name, I should be able to get back more than one. So by default, I'm going to get an array back. I can get elements by name, get elements by tag name, get elements by tag name NS. We're not going to deal with namespaces right now. And all of these are great ways to access things. And they exist, and they're useful. But I'm going to say, now that you know that they exist, I'm going to give you such a better tool for dealing with this. Query selector. So there's two query selector methods. We can see them there, query selector and query selector all. You can guess what the difference is between the two. Query selector, I'm going to get the first one that matches. Query selector all, I'm going to get all of the elements that match. And the reason I want to hand you this tool is because you already have the knowledge of how to write a bit of code that will give you the ability to match elements on the page. They're called CSS selectors. You already know how to write ID selectors, class selectors, tag selectors, descendant selectors, nested selectors. Went over all that yesterday. You know, when, for example, when Carl did the example about div.primary versus div space .primary, those are two very different selectors. And depending on the specificity of what you're trying to fetch, you would use them in different ways and write CSS rules around them. So why learn something new? If I use query selector, I can just type main. Boom, there's main. For example, I have both of these boxes, the red one and the blue one, have class box on them. It was incredibly descriptive. So I've got class box on both of them. One is ID red, one is ID blue. So I can do document.querySelector.box, just like I would with a CSS selector. And when I do that, you'll notice that I get back the first one, red, the red box. That's because I used query selector. If I change that and do query selector all, I get back a node list, which is two elements. And if I open those up, I've got one that is my red box and one that is my blue box. So query selector versus query selector all, one versus many. If I want to select an ID, query selector hash red. And I get access to that one thing. So rather than having to memorize the capitalization and the pluralization of get element by ID, get elements by class name, get elements by tag name, they are there. You can use them. They work. You'll see them a lot on Stack Overflow and probably blindly copy and paste them into your code and go, ha, I fixed it. By the way, don't do that. Query selector is a far more universal tool. It is your Swiss Army knife. It is going to be your one-stop shop to be able to get access to any element on your page as long as you can write the CSS selector to find it. And then if you need one or you need many, it's a very clear distinction between those two methods. Okay, any questions so far? We're still feeling pretty good. Haven't lost anybody. Nobody's brain is melting. Cool. So Why is it important for me to be able to access these things? Well, what if, for example, I wanted to change, modify, interact with one of these, elements on my page? What if, for example, let's say var box equals document.querySelector. I'll just do dot box, and that'll give me the first one. So box points to this right here, this red box right here. So now I can say box dot style dot background color equals green. Now you'll notice that I had to write the property name differently than I would if it was a CSS property. That's because it is a JavaScript property and we don't put dashes in JavaScript properties. You wanted something easy, sorry. But there is a pretty easy rule. If it is two words separated by hyphens, like padding left or background color or text align, that are a lot of the common properties that we would use in CSS, take the dash version and turn it into camel case. If only you had had a test that had a function that taught you how to do, never mind, too soon. Yeah, just take the dashed version and turn it into camel case, and you have the JavaScript property for that particular CSS attribute. And they are all under a property called style, because it is the style of the element. The reason it's called style, by the way, there's a really, really good reason it's called style and not CSS. Anyone want to take a logical leap and guess what it is? Yes, ma'am.
Style came before CSS?
Style did come before CSS, but where did style live?
In the inline.
Yes, the inline styles. If I have a stack of virtual cookies, you just got one. It's gluten-free, vegan, calorie-free. Well, cookies are made from wheat, and wheat is a grain, therefore cookies are healthy. So that's how I rationalize it clearly. So I am now able to select an element, and I am able to modify that element, which means theoretically I could do something like click on a button on my page and programmatically change the color of a box. That sounds like a thing that I might do. If only my page had a button on it. And with that in mind, let's go ahead and take a break there before we dive into events. And so, yeah, come back in about 10 minutes and we will talk all about events in the browser and how we interact with them.
Look at the gray. Look at the corner over there.
Yes, the beautiful hues of gray that we have.
I like it.
I like it.
Makes me feel better about being inside.
But presentation, compliments branch here are disgusting.
Okay, so I'm going to rein this back in now. Victoria, we're having a very stimulating conversation about expensive booze and box wine. So, I said that after the break we were going to get into events because we reached that point where we started to programmatically interact with objects. So here's where I have to peel back the curtain just a little bit further. You can see that I have the event reference page up from MDN. And I'm just going to start scrolling. This might take a while. All of these are events that happen in the browser. Still going, and I'm not even halfway down the page. Still going. Anybody hear an Energizer Bunny? Like, all of these are different events that can happen in the browser for different things. There are a lot of them. There's, I think, 380-something different events that can happen. And so that brings us to a fact about JavaScript. JavaScript is an event-driven language. And so when I say an event-driven language, I mean that the language is built around the idea that things happen in the language in response to some event. Let's think about Express for just a moment. The whole point of Express, when you run your server file in Express, the whole point of it is to register a whole bunch of callback functions that are going to happen in the event of a request coming in that matches one of the routes you've configured. If you think about what you have learned so far about making asynchronous requests, like making requests out to GitHub, what did you do? You set up handlers that would happen in the event of the request coming back with the data you requested. Basically, everything we do in JavaScript is built around this idea of events and built around this idea of callbacks. That's why we emphasized it so much, about 100 million years ago in week 1. Because if I walk down to Gastown and I find Crazy Eddie on the corner yelling at the lamp pole, and I punch him across the face, he's going to probably swing back at me. That's an event and a callback. If I walk up and hug him, if I walk up and give him $20, if I give him a sandwich, each one of those events is going to produce a different response. And that's because there's a lot of things in our world that are also event-driven, and JavaScript models that for us. So when we are at the point where we are wanting to fully embrace this idea right here of JavaScript interacting with the context that we have set, we now need to start learning about what events are and how we interact with them. So JavaScript was originally invented for the browser. The way that people use browsers is they tend to scroll, type, click, select. Those types of actions is how we interact with the content on the page. So those things are all events that we can watch for happening. And in the context of JavaScript, we say that we listen for an event. So we listen for a click. We listen for a key up or a key down. We listen for the mouse going into a box or out of a box. And so we have a whole class of functions that are called event listeners. And we can add event listeners to any element on the page and have it listen for one or more events that we want it to respond to. So if I come back to my page here, here's my big old button, and I can click on it all I want and it does nothing because it's just a button tag. There's no other code associated with that. But what I can do is I can find my button. And if I look at button, I see that I have selected my button. I gave it an ID, which we'll work with later, but it's the only button on the page, so it made it easy to find. And so now that I have that, I can say button add event listener. Camel cased, as all JavaScript functions are. So I'm adding the ability for this button to respond to a particular event. So when I add an event listener, it's going to take two parameters. The first is a string, which is the event I want it to listen for. The second is my callback function, what I want it to do when that event happens. So I'm going to listen for a click, and my callback function is just going to alert, hi. Quick note, Chrome, Firefox both fully support ES6 in the browser. So const, let, fat arrow functions, destructuring. I don't think the spread operator is there yet, but most of the ES6 features that you would use are there in the browser, and so it's relatively safe. That being said, I can't guarantee that Safari and Microsoft Edge are as fully up to date. But if you are ever curious, you can always go to caniuse.com and look up something like arrow functions. And currently, yes, we are good. This says that Safari as of version 12, Edge from 12 to 17, Opera 50, well, Opera's using Blink, so it's totally fine. Even iOS Safari works. What doesn't work is Opera Mini that nobody cares about, the BlackBerry browser, which nobody cares about, and IE, which nobody should care about anymore. So looks like we're pretty good, for example, with using fat arrow functions in the browser. But if you are ever curious, please check Can I Use before you use a feature, just to make sure that it is supported. I've got my function here that's going to run in response to this event. And so now that I have done that, I click on my button, and my browser says hi. Hi, browser. And doesn't matter how many times I do that, it's going to keep doing the same thing, because I have told it from now on until this page goes away, when I click on that button, do this thing. Make sense? Cool. So, we said that what we wanted to do was we wanted to be able to have it so that we could click on the button and change the color of our box. So, what I'm going to do now is actually bring up the JavaScript file that I have connected to this HTML, and we will start to write out our code here, because writing out a lengthy function like that in the dev tools gets painful pretty quickly. So, so here we have a couple of things that we're going to want to do. Let's start off with the same idea. And I'm going to go ahead and I'm going to use the ID that I assigned to that button. There's a couple reasons for doing this. Yes, right now, this is the only button on the page, and I could just use query selector button, and it would work. But what happens if I come back later and add another button to the page that I want it to do something else? Won't work. Now that I have this, I want to add an event listener for click. Pardon me. And what I want to do, let's think about the human logic of this. When I click on the button, I want it to find the red box, and I want it to turn the red box green. Okay, so step one, find the red box. Done. Turn the red box green. Cool. Done. By the way, you still have to spell it the American way. You can't spell it the proper way. It's still COLOR, unfortunately. You'd think JavaScript would have gotten that right, but no. So now I've got a function here that when I click on the button, it's going to run that function. So I come back to my page. I'm going to refresh. My box goes back to red. And cannot read property add event listener of null. Huh. Well, that's interesting. Why am I getting that error? I mean, the fave icon, that makes sense. This is just a page running on my machine. I don't have a fave icon. But why am I getting this? So I can click on this, and this is going to bring me over to my Sources tab. And the Sources tab is great because it actually will show me the scripts running on my page in a way that I can interact with them as a dev. And what it's telling me is that right here at this point, cannot read property add event listener of null. Yeah.
I think I know why.
Shmoo thinks she knows why. Why do you think that?
Because you've got the script tag above all the HTML.
And having the script tag above the HTML causes what problem?
The JavaScript runs first.
Yep.
And the HTML is not loaded yet, so it can't find buttons. So it's saying, where's the button? It's not there.
You get your second virtual cookie. Yes, so what Shmoo explained was where I have my script tag is in the head of the page. So that means it is one of the very first things that the browser processes. And having that up there means that if the browser is processing that first, it hasn't processed the body of the page yet, which means there is no button with ID the button to find to bind an event listener to. So my document.querySelector returned null because it didn't find anything. So when we get to jQuery this afternoon, we will have the easiest, cleanest, most perfect way of solving this problem, and it will make this problem go away magically. I'm going to solve this problem in kind of the old-fashioned way, where what I'm going to do is I'm going to take my script tag out of my head, and I'm going to move it down here to the very bottom of my body, so that all of the HTML above it will have been processed and loaded into the DOM before I try and run that script. So, with that in mind, I'm going to go back here and refresh this. And now, my button jumped for some reason. Fun. Now I click my button and it goes green. Make sense? Because that's what we told it to do. But there's something else cool going on here that I want to show you. So I'm going to come over to my script file, and I'm going to give my callback function a parameter. What the browser will do automatically is when the callback function is run in response to an event, it will pass a parameter, which I can optionally take advantage of if I want to. Yay, JavaScript. But it is the event object. And there's a couple of really cool things in here. And what we're going to do is we're going to console.log out the event object, just so that we can see what it is. So let's open this, and actually let's put this over here, so that way it's a little bit easier to see. So I clicked on my button, and there's the event object over on the right-hand side. We can see that it is a mouse event, and we can start to see some of the properties that are associated with this, but I'll expand it out, and you can see that there's a fair number of properties that we have access to. And we can start to see some of the things that we can check or interact with programmatically with this event. For example, I'm going to start with the very first property there, alt key false. What do you think that means?
You don't have the alt key.
I was not pressing the alt key, which means I can now check when I click on something, whether or not I was holding down Alt when I did it, and have it do something completely different. If event.alt key, do this, else do the other thing. That sounds fun. We'll get back to bubbles. It's not Trailer Park Boys, I promise. Some of the other things that are useful to look at, client X and client Y, 403 and 346. That is the exact pixel that I clicked on in this window. 00 is in the upper left-hand corner. So that's 403X and 346Y. So if we were looking at the standard Cartesian graph, we're always looking at the bottom, for you guys, bottom right-hand corner of a Cartesian graph, with 00 being in the upper left-hand corner. So that means we can tell when somebody clicked on something. You'll see this a lot when people make JavaScript games. Or, if there's a couple different icons, you could actually programmatically find which one was clicked on if you know the size. Control key false. I didn't have the control key down. A whole bunch of other stuff that's going on. Shift key false, screen X, screen Y, page X, page Y. You will notice that the client and the page are the same number because mainly because I've got my window full screened. So the page that we're on and the client that we're in, the XY is going to be the same thing. But if I scroll down here, there's screen X and screen Y. There's a pretty obvious difference between the two. Screen X is in relation to my entire screen. So upper left-hand corner of that is, way up here. And one of the other things, and this is something that you want to know, is that there is a target property on the event, and that is always the element that received the event. So the event target was the button. We can see what type of event it was. It was a click event, because this could have been a mouse over event, or a mouse leave event, or a key down, key up, or any of that other list of 380 odd events. The type tells us what type of event it was. So, and there's also just an X and a Y property, which is the same as the client and the page. So if you just want client.x e.x and e.y, or event.x, event.y, it's easy to get access to that. So there's a lot of really interesting information in the event object that we are able to take advantage of. We're going to add another element to our page so that we can take advantage of a different one. So let's put it down here at the bottom of our main. Anchor tag should always have a title attribute. So I'm just adding an anchor tag down here. And when we load that up, it's just going to be your standard ugly blue link, because I haven't styled the anchor tags, because I didn't have one on the page at that point. And so here's what I'm going to do. I'm going to look up that anchor tag, if I remember how to type. I'm going to listen for a click event on that one. I'm going to pass my event object again. Now, first off, we're just going to have an alert there, because I want to show you something interesting about the alert box in the browser. So when I click on this, we get the alert box that the link was clicked. But this is a link that should be sending me to another page, right? Well, alerts are what we call blocking events. The event of an alert box coming up stops everything else that's happening in the browser. Once I close this box, then the default behavior of the link is followed. But now we're going to change this to do something slightly different. One of the cool things that you can do with the event object, I'm not sick, I promise. One of the really cool things you can do with the event object is run a method on it. It's a built-in object in the browser. It has its own whole set of methods that we can interact with. And one of the main methods that you're going to use on the event object is called prevent default. As you might guess by the name, for those of you that read Sherlock Holmes novels, prevent default stops whatever the default behavior for that event is. So, interestingly, if you think about an anchor tag in the browser, the A tag has a defined style. It also has a defined behavior. So when the browser is parsing our HTML and it finds an anchor tag, it knows to attach, it's like a click handler basically, this click listener, similar to what we've done. It attaches one by default because of the type of tag it is. It has that prescribed behavior. Think of also like the submit button on a function. On a form. The submit button on a form, when we click on that and that form submits, there's a prescribed behavior, a default behavior attached to that. Well, what event.prevent default gives us the ability to do is to stop that from happening. So, now what I can do is I click on the link, I get my alert, and that's all that happens. Even though that the href of the link hasn't changed, it's still set to go to Google, but I haven't gone there because I've prevented that default behavior. And there's a number of cases where you might want to, to do this, where you want to check something programmatically before you move on. I'll give you a really good example. You remember about 5 years ago when every single site you signed into on the web, when you registered the first time, they had that password strength meter? And so you had to like get your dog to roll around on the keyboard before you could actually submit to set that password. So what was happening there is each time you would press a key in that form, that was triggering an event. And when it listened for that event happening, it checked what was in that box, determined if it matched the rules. If it did, then it would let it go through. Otherwise, the default behavior of submitting was prevented. So that kind of thing, where you have to make sure you type 10 digits into the phone box, or, the password checker, or all those types of behaviors where you see things getting validated online before like a form can be submitted, that is the prevent default kind of behavior. Yeah. Can I repeat the first sentence of that paragraph? It cut out entirely. Great question. Thank you, Aaron. I'm expecting them to come back and just say yes. All the paragraphs, please.
Restart the whole lecture.
Yeah. Can you start at the part where the internet works? Week 1, day 3. Yeah, okay. So there's this thing called JavaScript. It's really cool. You might want to use it.
Dog rolls on the keyboard.
Oh, yeah, okay. So, yeah, after the dog rolls on the keyboard, there's a box there that's listening for keys being pressed. And when keys are pressed, it evaluates the content of the box against the rules for a strong password. And it can prevent the form from submitting and making that your password if it doesn't match the rules. So that's one of the very common cases of using event.preventDefault. Oh, somebody found my emoji. Okay. So now we are in an interesting position, because if we can bind our own callback functions to events in the browser, we can now make our content respond to whatever event we want. We're now able to make everything on this page interactive, because we have the ability to find elements on the page. We have the ability to interact with them, change all their properties, and now we can take advantage of the fact that the client, our browser, is really just a big conduit for everything we are doing inside this page. Like, it's just listening for each and everything that we might do, even scrolling, even just moving the mouse around is going to create an event. So in saying that, that's what leads us to the world of what web application. Was that a question, Clive, or a stretch?
Yeah, it's a question. I'm just wondering if you could show an example of us calling, like, or pulling that event, like the timestamp, for example, of a particular click.
Okay. Oh, so okay.
One of the parts of the object. I just want to make sure, because I didn't see the prevent default as a part of the object. So.
Okay. Okay. So yeah, the request there is to be able to pull out you said the timestamp for the click? Okay. So yeah, we want to know when a click happened in this particular case. So what we can do here is, let's do this. We've added this, and now I am going to add a strong tag, which is different than strong bad. And in our event listener for our click, what we're going to do is we are going to find that strong tag. And whenever I want to change the content of a tag, I have two ways to do it. And there are two different properties that I can set. One of them is inner text. The other is inner HTML. There's a very clear difference between them, and it's not just 4 letters. It is that the inner text, whatever I set in there, is only going to be parsed as plain text. Whereas the inner HTML property, I have the ability to put HTML into that and have the browser turn all of the HTML into DOM nodes. So depending on how I want to interact with it is going to determine which property I want to use. Most of the time, I'm probably just going to want to use inner text, because most of the time I'm just changing the text content. But if I needed to add an emphasis tag in there, or if I needed to wrap it in a paragraph tag or something along those lines, I could use inner HTML to do that. There's a better way, which I'll show you in a minute, but those two properties do exist. So I'm going to set the inner text. And I'm going to set it to, whoops. I'm going to set it to this, just, what the time is now. That should work, knock on wood. Carry the 2, yes, okay. So we don't see the strong tag initially because there's no content in it, but it's there on the page. And when I click on that, nothing happens, which is totally what I wanted to have happen, which means I probably got an error. Date.now is not a function. Blarg. I have a particular blind spot in my memory, which is date objects. Every language I have ever worked in, JavaScript, PHP, Ruby, pick one, anytime I need to do something with a date, I always screw it up the first time and have to go Google the docs. This is proof that developers are human, even if you've been doing it for a long time.
There's an actual timestamp
In the event object?
Yeah.
That's the one that
Oh, okay. You want that one. Cool. That saves me the embarrassment of digging through the documentation. That's totally what I meant to do. So,
Event dot timestamp or whatever it's called, right? Yeah.
well, let's peek at it one more time to find it. I will click on this. Yay, link was clicked. And if we scroll down, timestamp, there we go. So the timestamp, so that's the time in milliseconds that the event took to happen.
Oh.
Yes. No, from the time that the event, so that's, okay, so let me trace this through for you. I clicked on the link, that ran the callback function. That callback function paused because the alert box came up. I clicked OK, and the function was able to finish. Let's do this a different way. I'm going to click on this. I will stand here and riff for just a moment, stroll back and forth, shuffle my feet, and then I will click OK. And the timestamp is much larger. So that is actually timing in milliseconds and microseconds how long the callback event, like how long the event processing took to happen. Yeah.
But in order to say you wanted to pull one of these values into your actual document, the event dot.
Event dot whatever the key property is. Yeah. Yep. So for example, let's just use the type property. It's nice and easy because it's a string. So what we can do, I'm going to cheat and I'm going to use a template string. And I'll do that. And in doing that, I'll reload. I will click. Link was clicked. And purely for demonstration purposes, I'm going to access my blue box. And I'm listening for the mouse enter property. I'm hoping that you can make the logical leap of what that's going to listen for. And so, actually, I need my event object. And I'm going to borrow my alert here. So, I will kill the console, refresh. So it doesn't do anything on the red one, but when I go over to the blue one, box was mouse entered. So yeah, programmatically, there's a new event object generated for every single event that happens, passed to the event handler as the first parameter, or first argument, and then I'm able to pull any of the properties out of that event object that I need in order to be able to make conditional decisions on what that should do. And it doesn't matter where I enter that from, even if I enter it from above. As soon as the mouse enters the boundary of that box, in this particular case, that event will get triggered. Down here, I have to actually click on that to get that event to trigger. And I'm going to be careful and avoid my blue box at this point. And we I'm going to avoid my blue box at this point, and we still have that event going. So every single element on the page, theoretically, we could attach a different event to. And you'll notice that I'm starting to get to the point where this JavaScript file is getting a little bit unwieldy. So what I would do in a case like this is I would start defining my functions and just passing them as callbacks. So let's go for function button click. And I'm going to move all this up here. And do that. So I've defined my function, and now I'm just passing the reference to that function to the event listener. In both cases, with what I had before and what I have now, I am passing the definition of that function to the event listener. You'll notice that I am not running the function here. I wasn't running the function before, because this is very different than that. That won't work. That will. And so just for demonstration purposes, since we have made that change, so that event handler now works as it did before, but I have cleaner code that I can interact with. Same thing here. Don't need that now. Here we get to do something kind of cool. If we don't need... Thank you, Josh. If we don't need necessarily the word link or box, if we just decide that we're going to say element was whatever event it was, then what we can say is function, let's just call it event handler. And what we will do is we will steal this. Oops. Well, actually, let's do this. We'll have a problem with that in just a minute, which I might be able to fix now. Mouse event, target. It doesn't have a name on it. We'll give it local. We'll use local name because we have node name and local name. Node name is in all caps, so we'll use local name. And so if that's our event handler, we will use it there. And we will use the same callback there. And so what will happen is, in both cases of clicking on the link and mousing over the blue box, it's going to trigger the event handler function on line 10 there. The event object gets passed as a param, just like it would before. We'll prevent whatever the default behavior was, which is only really going to apply to the link in this case. And then we will alert out that the local name, which will be the name of the tag, was whatever type of event it was. And that will give us some cleaner code. Shh, stop that. So, A was clicked. Article was mouse entered. Same event handler, but handling two very different events and modifying the output dynamically based on whichever element we're interacting with. So that becomes kind of cool because now, for example, if I, let's say I'm on Amazon and I click on the plus button, that's on the far right of an item listing because I want to add it to my cart, or I select a whole bunch of things and I click on add to cart, I can technically have the same behavior happen for multiple interactions on a page. Kind of cool. And it dries out my code. And also theoretically now, because modularization is something that we would still encourage as a good JavaScript practice, I could have these functions even defined somewhere else in another file. And as long as they are in scope when this file gets loaded, they're defined in the right scope, then I can put references to them here, and that cleans up this file even further. So that's how I start managing this code. I will say, overall, as a general rule, you will find client-side JavaScript to be more verbose than server-side JavaScript. And that's a nature of the names of some of the functions that we have, like add event listener. Now, last thing we're going to do here. Johan says it seems the logic inside each event listener. Sammy, we should organize our single page JS file like so. Functions at the top, followed by variable declarations, event listener pairs. Yes. Functions at the top, functions before you use them is always going to be your best practice. And generally what you will see is all of the functions defined at the top and then the actual work of the code happening at the bottom. No, not really any different than how you would write a script on the back end. You're still going to do the same thing. Logic inside each event listener is very limited, only modifying data once. Could you possibly do something like having a button? If you click it, once it changes to a new color and click second time, the color goes back to the original. Of course. Absolutely. Let's do that with our button click here. If box.style.background color equals red, else box.style.background color equals red. And I could easily write that as a ternary, and it would be arguably cleaner. But for clarity's sake, I'm going to keep it as it is now. Stop that. That mouse enter is going to kill me. So, the logic inside of an event handler is limited only by my imagination. It's limited by my ability to access and write logic around the data that I want to interact with. So, if I want to do something more complex, I simply write more complex code at the end of the day. It's just going to, like I said, it's going to be a little bit more verbose because of the property names and the function names that we are dealing with. So, last thing I want to show is how we can programmatically create elements on our page. So, let's say hypothetically we were building an app that was, I don't know, a clone of Twitter. Crazy, I know, work with me here for just a minute, thought experiment. And theoretically, I wanted to be able to create new elements on my page. So there's a couple different ways I can do it. I talked about that inner HTML property and how I can pass a string to it and have that string be interpreted as HTML. But I also have the ability to programmatically create elements and work with them using logic, rather than just, dropping a blob of text on the browser and going, here, you deal with it, which is effectively what I'm doing with the inner HTML property. So what we're going to take a look at here, let's load up index.html. And let's come back down here. I'm going to get rid of my strong tag because I don't need it. And I'm going to make a UL. And I've given it an ID of my list just to make it easy to target that specific UL. And I'm going to change the behavior of my big ol' button. I'll keep the old code just, so that we can reference it later when I send the code out. But I'm going to change its behavior. And that's the really nice thing about having the callback handlers defined outside, is I can leave that function sitting there and now define a new function that's going to do something else and just swap it out on line 22 here. instead of having to now copy and paste a whole block of code and rename it and hope that I get the indentation and hope that I matched up all the parentheses and everything. No, literally all I have to do is change one word on that line, and it's far more easier to swap out these behaviors. So we're going to call it button click 2, which is going to make it even easier to edit. So what button click 2 is going to do is I defined a UL, and ULs are pointless without list items in them. So when I click my button, it's going to add a new list item to my list. So what I want to do is start off by finding that list. Again, using my ID selector so that I'm guaranteeing that I'm getting that one unique list. And then I want to access my document object, the big master document object, and I want to use the create element function because I'm creating a new HTML element. And I'm going to create an LI. And I'm going to catch this in a variable. And I'm going to set the inner text of this. Actually, let's do something kind of cool. Let's say let's do that. So document.querySelectorAll, I'm going to find all of the LIs on the page, and I'm going to get the length of that array. That's going to tell me how many LIs there are. So when the first one gets added, there will be one list items. When the second one gets added, the document.querySelectorAll will find one, and I'll be adding a new one, so now it will say there are two list items. And then here's what I have to do. I have to say list append child li. So the language that we use when we talk about parent elements, sibling elements, child elements, carries through to the functions that we run. I have created this new element, but right now it's just sitting in memory. Until I run line 20, this li is just sitting in memory. JavaScript is just holding it in the browser's memory, in the operating system memory, until I actually put it into the DOM. The UL already exists. It's in the page. It gets parsed when the page gets loaded. But in this particular case, what's happening is I'm creating a new element in the document object, but it doesn't actually show up in the DOM until I give it a parent. And I do that by taking my list and appending the child. So we've got that function defined. So I will change that to button click 2. In fact, what I will do is comment that one out and leave it as button click, just so that you can see what it was before. I'm going to aggressively knock on metal. And ta-da. So now I am able to click on a button, listen for that event, take that event, and now theoretically reconstruct my page with it. I could also go to the style properties of my boxes and change display from block to none. Poof, they disappear. I could, decide to change the font family of my entire page, set it to Comic Sans and make all of your eyes cry, which would just be sad. Josh is asking, in the reading yesterday it said not to use ID tags very often, but in examples there are plenty. What is too many? So really good question, because now we're getting into a philosophical question. I'm using a lot of ID tags because right now, because I want to give the example of finding one unique element on a page. Most likely on a more complex page in a real application, I'm going to have multiple articles. I'm going to have multiple ULs. I'm going to have, all kinds of different instances of elements going on this page. So if I use very generic selectors like document.querySelector UL or document.querySelector article, it's going to provide way too generic of a set of results, and I'm going to have to drill down to find what I'm looking for. That puts me in the position of using methods like .filter, .find, and if I have an ID, it allows me to target more specifically. In general, there's a school of thought that says that classes are better than IDs. There's actually something kind of interesting that happens with IDs that a lot of people don't realize. So I have an ID on my button called the button. So over here in my JavaScript console, I'm just going to type the button. And I get a reference to my button back. Little known fact is that IDs create global variables. So one of the rules I'd like to give you, and I say rule this time in a pretty strict sense, this isn't a guideline or a best practice, don't change the ID on a DOM element. Once you set an ID, do not programmatically change it. That is not the way to change CSS. Once an ID is set, because it creates this global variable, if you change the ID and set a new one, you don't have a guarantee that the old property has gotten cleaned up. And so things that are programmatically addressing that might not get the element that they are expecting. And that creates just a small memory leak, which is a bad thing to have in your code. It's not like it's going to crash the browser or anything, but it's a really, really bad practice. So don't programmatically change IDs. Yes, they are just attributes that you can access, but don't change them because they do create global variables. As far as how many to use, you're going to use as many as you need to handle CSS specificity and to be able to effectively bind the JavaScript events that you're listing for to that element. I've seen pages that had literally 500 IDs on them. I've seen pages that had none. Your mileage may vary, your use case may vary. So use your best judgment. If there is a way for you to write a selector that uniquely picks one element on the page and you don't have to put an ID on it, then don't. The query selector engine is very, very fast. That's not what you need to worry about. So if there's a way for you to write better selectors, same rule for your CSS, write better selectors. But if there's no way for you to get to that particular element consistently, uniquely, that might be the time for that one element that you might need an ID. If it's a shared behavior where multiple elements on the page are going to share the same behavior, that's a class. Doesn't matter whether we're talking about CSS or JavaScript, that's still a class. Because when we add a class attribute, that's part of our HTML, which is setting context. So the context is, by having that class attribute, that this has shared properties with other elements that also have that same attribute. Yeah?
Is that like a functional thing or like a guidelines thing? I know ID creates this object that presumably class doesn't, but let's just say I didn't know the difference and I wasn't paying attention. If I used IDs as a class, would it still work as a class?
Okay, so
Yeah,
so the question is that more of a functional thing where if you are what I will affectionately call cowboy coding, finger guns, if you're doing that and you're just using IDs willy-nilly, the thing you have to remember is that IDs only ever apply to one unique element. So if you try and share that ID across another element, it's not going to work. Because ID by default is the first one the DOM finds that matches that particular thing. You may get it to work for CSS, but I doubt it. Definitely not for JavaScript. Yeah. And you'll have that moment of just banging your head against the wall. Why isn't this working? And you're going to realize that you have two elements with the same ID. Yeah. Yeah. No problem. Josh asks, so it is a good practice to backfill IDs. I don't want to say it's good. I don't want to say it's bad. I'm just going to say use them as you need them.
Clarify what backfill means?
Yeah, so if I write my page, clarifying what backfill means, if I write my page, I've written all my HTML, and then I'm starting to add my JavaScript, and I'm like, oh, I need to, then I would go back and add an ID to something. Yeah, I might do that if I can't figure out a good selector to get to that element that I need to target. Yeah, no problem. Cool. So, just to kind of sum everything up. Oh, you had a question? Yeah, sure. Oh, whoever's first.
Yeah, remove event listener.
Mm-hmm.
Starting to read a little bit about that, not really seeing how or like what the point would be. Is that just so that it only happens once or?
Okay, so the question is about the method remove event listener. What's the purpose of doing that? Would it be, for example, you only wanted something to work once? So a really good example of that is, let's say, for example, you are filling out, I don't know, a survey, and you're allowed to have up to 3 answers that you can give on the survey, but they give you a box, and they give you a button to add another field, right? So you type it in, you're like, okay, I do want to give another answer, add a field, which populates another box, just like what we did here with the LI. You type in, add another field. At that point, once I have 3 boxes, I would want to remove that event listener from that button. I would not want that button to work anymore. So I could set the disabled property on it. I can remove the event listener from it. There's a couple different ways, that I can address that. One-time use things, like some people will actually remove the event listener from buttons once you click on something. Like, let's say you're going to click to check out of a cart. They don't want you clicking multiple times because then you get charged multiple times. And so I've seen people write code that will remove the event listener for something like that. It could also be that, for example, ad blockers. One of the things that ad blockers will do is remove event listeners that have been added to buttons and anchor links where ad companies are tracking where on a page you have clicked. Because a lot of times when ads come in, you don't realize all the other code that they have run on your page to track whether or not you clicked on a link, whether or not you filled in a form, how far down the page you scrolled. Like those kinds of things, because they're all event driven, they can be listened to and therefore tracked. So a lot of ad blockers will remove event listeners so that those things don't happen. And it can also be that, you've got something like, click to show this, and actually, here's a great example. Everywhere you go now, you get the little pop-up like, hey, this site uses cookies. You might click to remove the event listener once you have closed that, because you don't want that ever to get triggered again. So it's in the case where that event both A, shouldn't run again, and also B, you want to make sure that it doesn't accidentally get triggered. That's the time to remove an event listener. I'll also tell you that 99.5% of the time you're not going to be doing that. You generally won't have to turn off a click handler or a form handler or something like that unless you really, really need to. And it's just good to know that when you do need to, there is the ability there to remove that. Oh, yeah, totally. Yeah, once I've shown it, I could totally tell it to turn itself off, and that probably would be a good idea for my sanity, if nothing else. You had a question?
Yeah, when you declare your variables in the example, I was wondering why you use query selector instead of get element by ID.
So why am I using query selector instead of get element by ID? Query selector is universal, so I don't have to worry about, because query selector is singular by default. I always know I'm going to get one result back from that. It's a heck of a lot easier to type than get element by ID. And I can use query selector whether I am querying by tag name, by class, or by ID. So it's universal. And mostly, it's far easier to type. And the behavior of it is more consistent because if I'm selecting by class name, by tag name, I'm going to get back an array that I then have to manipulate, even if it's one result. And I can specify query selector all if I want to get a set back, which is what I did with the list items. I would honestly call that just a best practice. Like I said earlier, the other methods are there. They do work. They were the predecessors to query selector. Yeah. Honestly, also not going to lie, some of it's just personal preference. I know people who absolutely swear by get element by ID. They never want to ever run query selector. For me, it's easier to type and makes more sense. You know, your mileage may vary. Cool. Yeah, recapping. We have a navigator object, we have a window object, we have a document object. Each one of them has a very different context for this big tabbed thing on the screen. Inside the document object is all of the elements that have been parsed by the browser. They've all been converted into JavaScript objects that we can interact with. There is a set of methods built into the document object to allow us to find them, to manipulate them, and once we know that we can manipulate them, the way that we interact is by using an event-driven model. So we wait for an event to happen in the browser and bind a callback function to that. And once we bind the callback function to that, the sky is then the limit for what we want to do in that particular callback function. We can change things, remove things, add things, whatever our imagination says needs to be done. At that point, it's business logic, not just program logic. So, anybody else have any other questions? Victoria, now's a good time to chime in as well. I have crickets and tumbleweeds. I'm going to take that as a good sign. Oh, Josh is typing. Oh. It's all Carl's fault. Going to code now on a Vim and a prayer. Oh boy. Okay. Pun game is strong. Cool. So yeah, I'll package these 3 files out. I'm also going to send you a link to. I'm going to send you a link to this image, and I'll include a link to the event reference on MDN, just in case you want to look through the whole list and cry just a little bit. Please do not think that you have to memorize all of them. That's what Google is for. So yeah, cool. Thanks, guys. Save it for the last day.